Hello and welcome to another episode of the Fully Charged Show podcast, where today we're talking about the unsung hero of the lithium-ion battery, graphite. Now, by volume, graphite makes up 95% of the anode. That is the positive side of the battery cell. And like many battery materials, the current supply chain is overwhelmingly concentrated in China. And as the EV industry endeavours to meet growing demand and to also diversify supply chains, that opens up the opportunity for companies like Quebec-based Nouveau Monde Graphite to step in. Now, Nouveau Monde Graphite, NMG, are on a mission to create carbon-neutral graphite. No mean feat when, of course, it involves digging it out of the ground and refining it. So, clearly, there is an absolute imperative to reduce the impact of mining these critical battery materials. But the question is, can it ever truly be sustainable? And do we really have a hope of diversifying supply chains? Well, very shortly, I'm going to be joined by CEO of NMG, Eric Desaulniers, who is here to answer all of our graphite-related grievances. But first, a very quick note from our sponsors.
This episode of the Fully Charged podcast is brought to you by OVO's Charge Anywhere. Charge Anywhere helps you power your car wherever you are, plan your route, and pay. You'll have access to over 34,000 chargers across the UK's largest charging networks and more than 400,000 chargers across Europe. Setup is easy. Just download the OVO Charge app, create your account, add payment details, hit the road, and start charging. There's no need to be an OVO customer either. Simply pay as you go or benefit from up to 15% off your charging with monthly boost packages. OVO's Charge Anywhere. Power your next journey with peace of mind.
So for those who might not be familiar, could you give us an overview of who is NMG and what are you trying to do?
So at NMG, it's a company I've started 13 years ago. Our goal was to discover a graphite deposit, the largest one possible for the booming lithium-ion battery market. And fortunate enough, that's what we successfully did 2 hours north of Montreal after airborne geophysics for like over 20,000 square kilometer, very large area of very grassroots exploration. That was my background in geophysics. And then we discovered a deposit, and we are now building the mine, building the transformation of the concentrate that will go out of the mine to serve the lithium-ion battery market. So we're building the largest fully integrated natural graphite operation in the Western world. And we have two very large customers, Panasonic Energy and GM, General Motors. So they are partnered with us to receive this very important graphite anode for their lithium-ion battery strategy in North America. So that, in a nutshell, that's what we do. We're 130 employee, about 40 and very motivated engineers, 10 PhDs. So to cover the full spectrum from mining operation with everything that is very technical in the mine, and all the way to the finished product, which is more electrochemist and quality control people. So it's a very, very fascinating company that has a lot of different expertise. Yeah.
And I'm really curious about the fact that you started in 2013, because no question, we did have a few electric vehicles. They were gaining in popularity. But I don't know exactly if anyone would have foresaw where we currently are now in 2024. And not only the volume of electric vehicles that we have on the road, but perhaps also the controversy that they can also cause. So I wonder, back in 2013, were you thinking, I want to be part of this graphite supply chain because I think it's going to be a really big opportunity to supply the EV industry? Or were you thinking about sort of other uses of graphite at that point?
But actually, it's twofold. You're right. There's also other usage for graphite. So there's only one significant mine of graphite in North America. It's actually located not too far where I live. So it's a 20-minute air time in an helicopter. So really, the foundation of the company was, okay, that mine is running out of graphite. It's operating since 30 years. I'm a geophysicist. I know how to discover graphite. And in 2013, the price for graphite, for some strategic reason, was like 3 times the price of today. So everyone were hiring me as a geophysicist. Please, can you find graphite mine for me? So I said, yeah, well, I can find a graphite mine for ourselves. So we use our technology to discover basically in the new world, in the Nouveau Monde, the next large deposit. But at the same time, the second aspect of it is it was the first announcement of the Gigafactory by Elon Musk. So he announced in 2013 the 40 gigawatt hour Gigafactory, and at the time this announcement, 40 gigawatt hour was more than the rest of the battery market total. It was a huge announcement. And we knew it would require about 40,000 tons of graphite. In North America, we're producing 15, 20,000 tons maximum since 30 years, and there's only one mine. So for sure, both things added together, let's do this, So it will be exciting. And at the time, it was 40 gigawatt hour, and now there's 1.5 terawatt hour of a battery announcement in the US only. So the market evolved, and we needed a bit of luck for this to happen. We needed our customer to execute on their strategy. And now we're really well positioned because developing a mine takes a long time. From early exploration all the way to production is something like 15 years minimum. It's a long time to discover, do everything right, environmentally speaking, to design the mine, permit it, build it. So it requires way more time than building a battery plant. So that's something that we're fortunate now to be very well positioned in the market.
And I guess at that time, back in 2013, you probably also wouldn't have foreseen the impact of the Inflation Reduction Act, in which those set of policies are trying to onshore or friendshore the battery material supply chain within North America. And you might not be able to comment on this, so we'll see. But if Panasonic is one of your customers, Panasonic supply Tesla, would it be a safe assumption to assume that the graphite from your mine will end up in Tesla vehicles?
Yeah, for sure. It's the right assumption because we're scheduled to send our product to Panasonic Energy mainly for their U.S. facilities, namely the Kansas plant that is currently in construction should start next year. I would say the start of their operation. So for sure, Panasonic not only have Tesla as customer, but that's probably the biggest customer they have. So it's a good assumption you would make. Yes.
So one of the things that's curious about graphite is that, when it comes to batteries, we spend so much time talking about nickel, manganese, cobalt, lithium, but we don't spend that much time talking about the anode, even though graphite takes up so much of the battery by volume. And I wonder if you could just share a bit of insights as to how important, how critical graphite is to a lithium-ion battery. And secondly, where is the supply chain currently placed, and why is it so important that we start to look at diversifying that supply chain?
Yes, for sure. Graphite is an active material, so it's a quite important and vital material in the battery. And his role is really to store the lithium ion when it goes in the anode, to intercalate the lithium ion in between graphite atoms. So it stay there while it's being used and then goes back reversibly very effectively to the cathode afterwards. So the graphite is really the reason why the reaction is so reversible, and you can charge and discharge many times the graphite. So it plays a vital role, and it's about, let's say, 1 kilogram per kilowatt hour of battery capacity is required of graphite. So it's quite a large amount. You're right, by volume and by weight, it's the largest material in the battery. So it's quite important. And today, 100% of the battery grade graphite comes from China. There's a little bit coming from company like us. We have a kind of small 2,000 ton capacity now, but in the general market, today, until we have built our project and we're in production and we're starting supplying to Panasonic and GM, like over 99% comes from China today. So I would say 2/3 of the flake concentrate comes from China, and there are great graphite mines outside China, like in Brazil, in Africa. There's a lot of new projects. There's project here in Canada. We have the right geology. That's one of our big strengths. We have the geology right here. However, those places where there are graphite mines, they don't have the infrastructure and the customer base typically to develop the full value chain. The big strength that we have here in Canada, in Quebec, where we live, is to have both the geology, to have great deposit, and within 2 hours drive of that great deposit, we have a very affordable hydroelectricity because it's very energy intensive. We have all the reagents, the chemical reagents needed in the transformation. So, and we have a large industrial complex. In fact, today I'm here in close to Bécancour plant where we are developing the transformation asset, and having everything around us, we're close by to the deposit and relatively close to our customers south of the border, is a unique situation to build a full vertical. So we can think that we can be very resilient cost wise and compete with China. So our customer have a good graphite anode solution. But today it's a China story, a little bit like rare earth, I would say. It's something that China really control. Yeah.
Yeah, it's so interesting because in researching this podcast, there are loads of diagrams that you can look at as to where the battery material supply chain is concentrated, and it's always in bar charts. And they have absolutely enormous bars in red that represent China, and then teeny tiny diddly ones that represent other nations. But there are a couple of things that I want to ask you about before we kind of get into the value of having that completely vertically integrated supply chain that you have in your operations. And firstly, I want to clarify some terms because we hear things like flake graphite, natural graphite, synthetic graphite. I don't know what the difference is between any of those. And I wonder if you could just kind of walk us through the different types of graphite and their significance.
Yeah, so what we do is natural graphite. So natural graphite means it was created by the nature directly into graphite. So there's three forms of carbon in the nature. There's coal that is like just a little hydrocarbon that a little bit overcook. But when you're a bit deeper in the crust and you have higher metamorphism, like let's say 10 kilometer of pressure, and then 3,000 degrees Celsius for millions of years, this coal become graphite, a bit higher metamorphism. And then if it goes even below over 150 kilometer, then you start creating diamond. So obviously it's difficult to go deep as 150 kilometers. So you need a kimberlite pipe to bring the diamond from the bottom of the continental shelf all the way on the top, so we can discover and mine it, the diamond. But however, the graphite, where we are located, our geology, there was 10 kilometers of rock a billion years ago. It was higher than the Himalaya, and all during a billion years, it eroded. So now we are looking at rocks that are highly metamorphosed to the grade that create very good graphite. So that's this graphite that was created by nature that we call natural graphite, and by a simple flotation process. So just crushing the rock, there's maybe 5% graphite in the rock. You crush the rock and the graphite is hydrophobic, so it won't float at the surface of the water. And then it's easy to extract this graphite, and it comes in form of flake because naturally it's in form of flake in the nature. So you float it and you generate a concentrate, typically above 95% if you want a good concentrate to start with, to start the processing of making anode material. And then on the synthetic part, it's a totally different thing. So they use a needle coke that is a residue of the oil refineries. So it's a very high carbon, highly crystalline coke that is, a small fraction of the whole decant oil that they produce. And then they use that coke and they shape it first and they graphitize to 3,000 degrees C for a few days to have the right quality. So it requires a lot of energy. It requires, the oil industry to produce more refineries, I guess, which is a bit paradoxal. So if you expect that oil business will slow down a little bit, why would they have more needle coke? So that's the challenge that the synthetic graphite have. It's higher carbon footprint, higher cost. However, it's a predictable quality, while in the nature, you need to have a process that handle a lot of different impurities and a lot of different form because it's natural. It's less of a recipe.
And is there a particular type of graphite, whether it's synthetic or it's flake, or synthetic versus natural graphite, that works better or has a greater efficiency within a battery?
Yeah. So they both are graphite at the end of the day. So they both fulfill the function that they should do. But when you get at the edge of developing more performant battery system, they both provide something different. So the high crystallinity of natural graphite, that cook for millions of years at 3000 degrees C, this high crystallinity brings more capacity typically. So natural graphite has a more capacity. For sure, it costs less to manufacture and less carbon footprint, as I've mentioned. But typically, this high crystallinity is creating a bit of swelling in the battery. So when you discharge, there's about 10% swelling for graphite. While synthetic graphite, it's better to handle the swelling because it's not as crystalline and it's isotropic. It's in all direction. It's less oriented. I would say the crystallinity is less oriented, so the swelling is easier to handle. So the cycle life typically of synthetic graphite is slightly better. And sometimes as well, the fast charging properties are slightly better on synthetic graphite. So all those great customers, they know exactly how to blend both natural and synthetic together and create an anode material that kind of fulfill all the needs they have. So if you have, for instance, a cylindrical cell with a cathode, nickel, cobalt, aluminum, you will have a certain recipe on the anode. You can even blend a little bit of silicon to enhance the capacity with the trade-off of reducing your cycle life. So they can play with that. So natural graphite, synthetic graphite, a bit of silicon additive to have the best recipe for the anode in relation with your chemistry and your form factor. If you do prismatic, pouch cell are very sensitive to swelling, for instance. So it's more difficult to put a high amount of natural graphite. So you need to know your customer and do the right product for them and sell your product at their specification and, don't try for now to reinvent. They know what they want. The large customer like Panasonic Energy and the tier one cell maker, you just need to make the right product for them. But it's fascinating to be in those meetings and really understanding the why of all the little specification and the story behind when they added those specification, what happened in the plant. So it's very good for us to work with such a Japanese partner and Koreans as well that are working with GM. Yeah.
It's so amazing because, you look at these materials which probably side by side look fairly similar. And then there is such a difference of what's going on in the electrochemistry on a sort of nano scale. And I always think that it's so extraordinary that something on the nanoscale can have such an outsized impact on a really, really global scale. I also think it's so interesting that so often whenever we ask a question on the Fully Charged Show and Everything Electric Show, often the answer is, it depends. And of course it does. And I think that's why it's so joyous to have these sorts of conversations where you can get sort of slightly into the nuance. But I also think it's interesting that, one day in a totally utopic world, it'd be lovely to fast forward to a future where you're not having to make a decision between synthetic or natural because we're recycling that material and it's not having to come from oil refineries or having to be dug out of the ground, but it's already in circulation and it's just being recycled. But at the moment, graphite isn't particularly well recycled or widely recycled. Why is that?
But first of all, it's difficult to compete on cost. Because graphite is very cost competitive. So it represents less than 10% of the battery cost per kilowatt hour. So sometimes it's easier for the cell maker just to buy a new ton, I guess, when it's not that price sensitive. Why would they risk a new material, for one? And for two as well, typically when you cycle like a used battery, when you cycle a lot, what happens is the SCI layer around the graphite becomes unstable and there's a lot of I would say impact on graphite on used batteries. So it's difficult really to break this and to recover everything. So when hydromet, because we're working on recycling a lot and with many different partners, and they kind of give us the black mass at the end of having extracted everything they could by typically hydrometallurgical processes. So they extract everything they can, and at the end they have this black mass that is typically 80 to 90% maximum, and with a lot of different things in it. And it's kind of difficult to purify this, and it's compare a concentrate that goes out of a mine at more than 95% purity, and it's very predictable purities, that you control in your process. So far the challenge is to really purify this black mass that contains a lot of different things in it, and develop a process as well that will fulfill the black mass that you receive from all the different recyclers, because they all have a different process and they all send you something different. So it's difficult to make a single process. But we're looking at it. For sure, we believe that in the future, we'll need to be able to put 1, 2, 3, 4, 5, 10% of recycled material within the anode material we sell to extend the mine life of the mine eventually. That's something we want to do to maybe not 100% recycled material to start with, but just start to put some powder that was recycled within the powder that is fresh. So that's something we're working on, but that's a difficult challenge technically. So maybe that recycled graphite will be going first in other market that are better, that are easier to sell into, that are more or less sensitive to impurities. Like lithium-ion battery market is very sensitive. You need to have a very good product at 99.9% plus purity, with very strict control on impurities. So that's the challenge. It's a very difficult product to do to start with. So having a recycled material is another challenge. Yes.
I'm going to really expose my ignorance, my electrochemistry ignorance here. But you said the SEI layer. That's the layer that's next to the electrolyte, if I'm correct.
Yeah, they call it a solid electrolyte interface.
That's it. And from what I understand is that actually that bit of the battery is really complicated, because you can kind of get active material being taken out of reaction. You can form sort of dendrites in that particular bit of the layer. And is what you're saying that graphite is very vulnerable to that active material being taken out of? God, I'm really fudging my words here. Please help me out here.
Yeah, but basically the SEI layer is with the graphite. So you need to get rid of it. And getting rid of the SEI layer in used graphite is an added challenge. It's easier to recycle graphite that comes from scrap. So non-conformance in battery creates scrap. So they sometimes startups in battery, they have very low yield in their plant. So they will have like 30 to 40% of scrap that wasn't cycled. So this graphite is easier to recover because there's no SEI layer that was formed by the cycling. So when you cycle many times the battery, the main reason the battery at some point is not good anymore, it's because of this SEI layer. It became like too big and part of many other things. So the garbage goes on the graphite. So you need to get rid of it in the recycling. Yeah.
That in my head, and this is, I know this is going to be so unscientific, and many of the technical people listening to this podcast are going to be quivering as I say this. But I suppose that SEI layer, its formation throughout a battery's life, is a bit like forming lime scale on a shower head or something like that. And it's sort of, you don't want it there, and it reduces the effectiveness of that battery, essentially.
Exactly. Yeah, that's exactly that. And it takes lithium from the cathode, and it make it passive. So that's why when you first charge and discharge your phone, you're super excited. Your phone like kind of is charged for 2-3 days, and you don't need to charge it. And at some point, the SEI layer is getting formed, and it's sucking a bit of lithium on the cathode, and there's less capacity because there's a bit of the capacity that went into forming the SEI layer, and that SEI layer is around the graphite. So when you want to recycle graphite, you need to remove this, and it's kind of big. It's kind of brick, It's difficult to purify.
That's, for anyone listening, now we can say when our phones start to, the battery life starts to diminish, we can say, oh gosh, that SEI layer is causing havoc.
Yeah, exactly. You can say that. Yeah.
Yeah. But what an interesting challenge that graphite, it's so critical from a volume and a weight perspective, and it's obviously a critical material. But you mentioned earlier that it represents less than 10% of the cost. And if recycling is really complex and it's really costly, that must become a very, very hard thing to justify. And what a complex engineering challenge that presents to you as an organization.
Yes, exactly. So that's why we know we need to play a role in that, because just building a 42,000 ton capacity plant, it's close to $1 billion. So we know the recyclers won't invest $1 billion into a processing facility for graphite. Like it would be unlikely. So it's our role to try to use our facility to recycle that graphite that comes from different sources. Otherwise, there's other market like recarburizer, like when you do drilling, the mud that they use to do drilling, for instance, in shale gas, you can put graphite in there just to have a lubricant, a solid lubricant. So there's markets like that are using hundreds of thousand ton of carbon source, and they like graphite for that, but that's cheap market. That's not market that provide a lot of value. So, we have the same issue. In our process, we have 50% yield, give or take. So we create 50% of very fine powder. So we have a similar challenge than the recycled graphite is we need to sell high volume, lower value product in different markets as well. So that's the good thing. Graphite is used in many different applications, and sometimes it's just a carbon source for in the steel making industry, for instance. So there's a lot of ways to use it in the market, but you should make your math properly to see what's the economics of doing that.
So last year, China restricted exports of graphite to the US. Did that materially have an impact on your operations or the graphite market more broadly?
You would believe so, huh? It should. It should be very worrisome for customers in North America to see that 100% of their supply comes from a country that kind of have a bit of a geopolitical issues with anyway U.S. now. So that's a worrisome. So yes, probably it created an emergency or an urgency to act from some cell maker that, after investing billions of dollars in building a cell factory, billions of dollars on the cathode side, they need the anode, even though it's less than 10% of the cost of the battery. If you don't have it, it doesn't work. You just lost 100% of your investment. Huh? So when China flex muscle and they say that they may not give graphite to North America, it should be very worrisome. So that's a bit created the sense of urgency, but a lot of those customers already had the strategy to develop localized supply chain. Like Panasonic is very vocal about their intention since many years of having 50% of localization of supply chain, reducing 50% their overall carbon footprint. So I don't believe this December 1st announcement changed anything in their strategy, but maybe it created a bit of urgency to act, because there's time. It needs time to build project. So even though we make the decision today, it will require over 2 years to build a project. So we need to act now. Yeah.
Okay, I want to return to your operation then, because not only are you making natural graphite, but you're trying to do so in the most environmentally responsible way possible. And I wonder if you could walk us through some of the things that are making that possible. I hear, for example, that there are electric vehicles operating in your mines.
Yes, for sure. So we needed really to understand the full vertical, what is the impact of our operations. And for sure at the mine, this is like key. If you want to get your permit in time, you need to demonstrate to very good people at the government of Quebec here in Canada. They know about mining, so they know what are the best practice. So we needed to exceed the best practice and demonstrate that that's the best way to build the mine. So for instance, an all-electric mine, for sure, the idea that we had in 2017 when we said we would do the mine all-electric is basically the only reason you would need 100,000 ton per annum big graphite mine is if everything goes electric, you know. So that was the bet. It's like, okay, let's announce an all electric mine, because if our mine is justified in this world, it's because everything goes electric, including the mining trucks. So we started program to convert ourselves. We have one on site that we converted ourselves. It's not a very productive piece of equipment, so we're super happy that our now partner Caterpillar went into this, and now they have a very serious and important project for them to convert not only one truck but the whole fleet, the dozer, the wheel loader, the excavator, the grader, the haul truck. So everything has a very specific timeline to be converted to all electric, and also the charging station and what we call the job site solution. So they will charge us per hour of usage of all those pieces of equipment. So it's not us that has a big capex. So it needed a lot of work. So this is important because we are reducing significantly our carbon footprint, but not only us, but also all the other customer of Caterpillar that will embrace that technology after they have developed. So that's something we're very happy to do. Not only our project, but just so this solution is available for any other open pit too. That's an uncalculated impact, I would say. But that's one. And also we need in the mine, we really need to take seriously the management of water. Water is very important. So now we have and also how the water flows on your tailings. So the tailings, the strategy we have is to do backfilling in the pit. After year 5, we can start backfilling behind us and do progressive restoration. So we are currently testing all those different vegetables or trees, that grass, a type of grass that will hold well on our tailings, to make sure we do progressive restoration. So at the end of the mine life, there will only be the last pit, I would say, that will be quite small. So that's progressive restoration, co-disposal of tailings to make sure they never generate acidity in the nature. So there is specific work we did on that. All electric mining, making sure we use in our plant hydroelectricity. So we have access to that affordable and green hydroelectricity, but it's our duty to make sure we use it 100%. So all our different processes are quite energy intensive. So we need to optimize the usage of hydro. So we're proud to say we're carbon neutral since inception, and we intend to remain so, in the future. And every year we are making a very good ESG report that is reviewed by third parties, and we can guarantee our customer a carbon neutral product. So it's a big advantage for them to reduce. Because one thing I would like to say on that I realized recently is, even though graphite is not that price impactful for the customer, so it's not that price sensitive, it's below 10%, is very carbon intensive in the battery. So because when they use synthetic graphite, it's close to 40 kilogram of CO2 equivalent per kilogram of anode material. So it's synthetic graphite is very nasty, and it's a big volume in the battery. So the impact on the battery system is like very large. It's about 40 to 50% of the carbon impact of the battery sometimes is on anode if you use 100% synthetic. Us, we are 1.23 kilogram of CO2 equivalent per kilogram of anode material. So for our customer, it's a good way to reduce their overall carbon footprint by not so much effort relatively to the cathode side, by supporting us, investing in our project, making sure we become their supplier. They reduce significantly their carbon impact just with one supplier, even though it's not that price intensive. I don't know if you follow my explanation, but that's something I realized, that beyond only having access to graphite, also the value that they have to reduce their carbon footprint, we are impactful in that sense. Yeah.
But that is extraordinary. So just to make sure that I've understood that if you were to have 100% synthetic graphite, you'd be looking at per kilo of synthetic graphite, it would be 40 kilos of CO2 equivalent.
I would say they say 24 to 40, depending on the how the synthetic graphite was, the needle coke was sourced and the energy used to do the synthetic graphite. Yeah.
And then conversely, your process is 1.23 kilos of CO2 equivalent per kilo of graphite. And earlier on, you said that we're talking about roughly 1 kilo of graphite per kilowatt hour of battery.
Yes. Ish.
And then if you kind of scale that up, so let's say average battery pack is 50 kilowatt hours to make the maths a bit easier. We're talking, potentially 200 kilos of CO2 equivalent with 100% synthetic versus 50.
Yeah.
So it's like one person, or like one of me versus 4 of me in CO2.
It's major.
Wow.
On the anode, it's very big impact. You're right. And on the cathode, it's difficult to control that because you have a mine at the end of the spectrum selling to a processor of a precursor, like if it's a lithium mine, lithium hydroxide, lithium carbonate, and then they sell to a PCAM producer who's selling to a CAM producer, and then it goes to the cell maker. So it's difficult for the cell maker to really control and trace his carbon footprint on the cathode side.
Wow.
So us, we are doing the full vertical. On the anode side, you need to do from mining all the way to the finished product if you want to be competitive with large Chinese conglomerates. So that's what we do. So on one supplier that is doing carbon neutrality, you're right. There's more impact on carbon than on money, for sure.
Yeah. And I suppose that's not something I'd really thought about, that actually if something isn't particularly price sensitive, but you have such an outsized impact on that carbon reduction, presumably, even if it is a little bit more expensive, people don't mind paying a bit of a premium for such a significant gain from a carbon footprint perspective.
You said it. I will never say that to my customer, but you said it.
The other thing, so last year, was it last year? Yeah, last year I went to visit a copper mine in British Columbia. And they also have a huge amount of hydroelectricity on site, and they were trialing electric trucks. I was just totally blown away by the scale of these things. I knew that mining involved big vehicles, but until you see these house-sized vehicles, it's unimaginable. But the other thing that we discovered whilst we were there is that because electric drivetrains, you can accelerate a bit quicker, particularly when you have these very, very enormous vehicles. Actually, there was an efficiency gain as well, because these vehicles could, over time, do more trips than their diesel equivalent, and obviously with less pollution. And of course, there was a cost benefit because running these vehicles on electricity was infinitely cheaper than running them on fuel. Is that something that you're also experiencing, those kind of secondary benefits of efficiency and cost saving?
Yeah, so we have attended demonstration with our customer Caterpillar. We need to be careful. We cannot reveal everything they're working on, but we have access to in Tucson, Arizona, to their site where they test their test site where they demonstrate their efficiency. And the 793, the large truck that they use I think it's a 240 tonner. So it's the 793. It's all electric. They announce it, and it's very impressive to see it behaving. I agree with you. They themselves were impressed about the productivity of that piece of equipment. So it was great to be there. We won't buy such a big truck. We have a smaller mine, so we are more on the 775, 60 tonners size truck. So it's between the first mining truck and the last size for construction trucks. So we're in between. So it's a truck that they sell way more. So it's good. There's more sales of that truck, but it's very exciting to see such high, the 793 all electric. I have a picture with my chief of operation in front of it. Like I look super tiny.
Yeah.
So that's impressive to see it being all electric now. No noise, almost no noise. It's great. Yeah.
Which is another kind of sensory strange thing, because you're seeing these quiet vehicles and their size means that the lack of noise is totally confusing. And I do think that, I don't think anyone is properly an adult. I think we all just pretend a little bit, but you get that real childlike joy of seeing these enormous trucks. It's just so exciting. So earlier on, you said that to build a mine, it is a 15-year process. It is a $1 billion thing to do. And so you have to have that really kind of long-term commitment to making this possible. And yet when we look at the news agenda right now, there is so much hysteria around, are we going to go for an electric future? Is it ridiculous? Do we have this massive slowdown, etc., etc.? Which I presume you must find very annoying, because it creates a lot of uncertainty in the market and you need that kind of long-term vision. How do you kind of deal with that sort of immediate term uncertainty generated in the media versus having that long-term goal and commitment to an electrified future?
No, yeah, you're totally right. We're building a generational project. It's not a project that will last 5 years. It's a project that will last longer than it took to develop it. Huh? So it's a mine life is 26 years, but we have a way bigger resource, so we can extend the mine life. We're confident we can do that. So it's a project that will stay there for a generation at least. And then the industrial project will be there like for a few generations for sure until we need it. And so that's so how we cope with that, with the investment of plus $1 billion plus in a generational project in a market that seems there's noise every quarter on technologies and stuff like that. So the only way we can cope with that is to have partners that really need what we do, and ask them the right commitment in their own strategy. For instance, Panasonic are really committed to their strategy, so that's why they invested in our project. They provided 7 years offtake agreement with very specific product. So basically, it's a commitment of 10 years. So because we need 3 years from now to build the project and finalize the project financing, and 7 years after that, they will keep buying the product. So we need such a customer who believe in their technology, believe in their strategy, and they're making this statement for us to finance the project and build it, and make sure that we can answer all questions from our investors, government, other stakeholders when they ask, okay, will graphite will still be used in 5 years because there's other technology, or there's a slowdown in EV and stuff like that. So now we're in it with larger corporation like GM and Panasonic. And that's really the reason why such a project as we have, like a startup company like us building a major project, there's no other way than having the best tier one partner with it to justify it. So that was the reason why since 2-3 years we were negotiating those offtakes, and we knew there was no way around having such a customer with us.
And I suppose also, Canada and Quebec especially have really identified the value of harnessing the supply chain that could exist in Canada. And presumably that's come with financial support, or at least kind of policy support as well.
Yeah, absolutely. We are well supported by Canadian government, Quebec government. There's a lot of different, but those are commercial discussion, like commercial loan and investment in equity. So that's all discussion we're having now with different organization within the governmental structure, and even with other government as well, where we're procuring equipments for building the project, or we sell a product. So should it be Japan, different Japanese organization, US, where most of our product will be sent, and a lot of equipments will come from US as well. So all those governmental bodies are key to make the supply chain alive. But all of them need to see customers who need the product being also important in the project financing structure. So that's why the commitment of GM and Panasonic toward their investment to build a project is key for all those governments who are less into the technical details. They need to have comfort that the one who are looking at the product will need it for a long time.
Whenever we talk about mining, it's always so challenging, because on the one hand, we see very clearly that we need to move towards this clean energy future, of which electrification is a huge part of that. Batteries, be it in electric vehicles or in stationary energy storage, are absolutely critical to making that possible. But whenever we talk about mining, we also have to recognize that we are digging things out of the ground. Even if there are efforts to restore the land and restore the biodiversity, there is an impact, and there's always a risk of a bigger impact than one could have anticipated. In Canada as well, we have to consider that there are First Nations communities who are stewards of the land, and their lives are perhaps more, well, definitely impacted more than people who are not part of First Nations communities. And so I wonder, how do you manage that? And how can you have that really, really future-proof plan such that communities are protected and the land ultimately can be restored?
Yes, absolutely. This is key. There's no mining project without the support of the communities, and honestly speaking, it was like when I started the company and I was exploring, probably the most stressful thing for me, because in 2013 when we went in the community of Saint-Michel-des-Saints where we're developing the project, there was two big moratorium that were just announced in Quebec, like on uranium. There was a moratorium, and on shale gas as well. So the trend was to be a bit anti-mining and make sure we don't develop the resource, especially the resource that are used in energy, because we have enough hydroelectricity. So the population were like, we don't need more energy source. So I was really taking this seriously. I was going there, and in fact, I'm going there still today with my family over Christmas all the time in the community. So we really took it seriously, asking, explaining in detail what we do without being shy of saying we will have an impact, but we will understand that impact. We need to know what you're worried about. We did a lot of open house, of town hall all the time to make sure the community express themselves and more importantly understands what we do. So we paid a lot of our consulting firm and engineers specialize in noise, specialize in dust, specialize in tailings. So they come, we make a booth, people can ask question every year. So that's something that was quite important to make sure we have the support of the community. We will never have 100% of people that are voting in favor of having a mine 5 kilometers away from the church, as we are very close to a town. However, we had in the 80s, like we did surveys, and we were 82%, 83% support. So I think showing that we were getting it right, I believe. So it's something that is never granted. So you always need to work on your relationship with the community, and you need to deliver on your promises and not make false statement. We'll make a hole. It will look like that. On our corporate video, we were showing what was a blast. Here's a blast that we will do. The rock will explode this way. It will look something like that, so people can have less unknown. So the local community is really Saint-Michel-des-Saints, but and it's within the Nitaskinan traditional land of the Atikamekw Nation. So you're right. So the Atikamekw Nation are proudly one of the nation that preserve their language. So 99% of the Atikamekw speaks Atikamekw between them. It's a great success story for preserving the language. The 50% of the community is below 20 years old, believe it or not. It's totally unexpected compared to the rest of us, in the Western world. So there's great opportunity to work with them and make sure they understand our project and they want to work on our full vertical. So we are very close to them, and we want to make sure they support us and they accept that we take a bit of the resource from the Nitaskinan to produce this important product for the battery value chain. And I believe they will be great partner during the project for sure.
It's so interesting because I was at an event this week and it was talking about how can we communicate the value of autonomous vehicles to the public. And so much of it always comes down to, I think the same is true of anything, really. It's that really clear communication, that really clear management of expectations, transparency, and including people in that conversation. And they sound like really basic things, but it's so astonishing how often that doesn't happen and how many problems it can cause as a consequence. But at the end of the mine's life, is it sort of... how much is kind of permanently scarred and it's a case of, well, let's do the best that we can to restore it, versus you would never know that a mine was there? What does that sort of long-term outlook look like?
But for sure, before in Quebec, before even opening the mine, you need to have a restoration plan that is approved by the government, and you pay it in advance. So us, it will be, I believe now, $34 million that we have agreed with the local community and the government. Here's what we'll do with the site afterward. And also something we're doing now that is, I could talk about that for a long time, but we call it the PIT. But in French, it's the Plan d'intégration au territoire, so plan of integration to the territory. So one of the things that the community were really worried is we have a negative impact on tourism. So instead of having a negative impact on tourism, we made a project to make sure we have a positive impact on tourism. So there's a small hill in front of our mining operation. So what we're doing now, in fact, we started this project already. So it's fully financed and by different organization. So we're doing 30 kilometers of mountain bike track with a big lookout at the top of the mountain, so people can look at our operation. And the 30 kilometers of mountain bike track will be like professionally made by top people here. That it will be a very good attraction for people. They can rent either EV electric bicycle, or if they're more in shape, they can use the real bicycle, and it will be very, very interesting. So we're super excited about that. So that's something that we have worked with the community, and they've created their non-profit organization, and we are like NMG a sponsor to this, and we made this promise, and we asked the government to put it in our decree. So we need to execute this by law. Like the electric mine, it's a promise that is now in our decree. So we have 5 years to fully electrify the mine, and we have to do this PIT, this integration project with the community. So we have a lot of little things like that I could talk about. That was after meeting everyone in the village and understanding what they would like to do, what are the awareness. Then we have ideas like that during the development, and we just do it. So this mine, after it finish, it will be already like a site that will have other function as well, like more like tourism. So for sure, we need to preserve the safety of the site, make sure during the first 10 years after the operation has stopped, you need to monitor the water all the time. You keep the site alive to make sure you monitor everything. But after 10 years, if you have demonstrated that everything is under control and it's fully restored, the government can release you of your obligation. So that's why it's important to today design a project that will, within 10 years, be fully restored and stable. You need to demonstrate that to the government. And if you need forever a water treatment plant, forever in a financial model is very expensive. So you need to pay for it in advance,
So we have been talking for 52 minutes, and it's clear that there is so much that is such an opportunity. There is a clear financial opportunity. There's a clear opportunity to create a graphite supply chain that is more resilient, that is cleaner, greener, etc., etc. But it's a long process. You started this journey in 2013. It's now 2024. I wonder what keeps you going. What keeps you going on this project that is long and difficult and complicated, and as we've spoken about today, has so many different components to it? What keeps you motivated?
Yeah, no, that's an important question. Every morning you need to ask yourself, huh? So, but now, for us, for me, it's easy. Like when it was only a startup with only me and another employee, it was easy to surrender. But now it's like a project that is beyond just me. Like we have tons of very important shareholder. It's a project important for large cell maker like Panasonic, GM, that are really important for this overall strategy in North America. So, and it's important for the local community. We see the First Nation, our friend, the Atikamekw, would like to benefit the most possible from this project, because mining project, they are typically projects in areas that have not a lot of other opportunities. So we are very important for the local community. So for me, it's easy today to wake up and always have the motivation to make sure we deliver this project. And we deliver more projects like that, because not only one will be necessary, many of those. So now that we've developed this expertise and we have 130 experts on graphite, we need to make sure that we develop the supply chain for the North American market. So everybody that comes work for us, they have kind of the same drive. They don't just come working for another company. They need to share that value. They need to believe in what we're doing. So I think it's a great things to do every day.
Well, honestly, it certainly sounds like it. And thank you so much for sharing your insights today and for taking us on a bit of a journey through the world of graphite. So thank you very much.
Thank you, and you're welcome right here in Quebec anytime.
Thank you so much to Eric for joining us on the show today. I personally found that absolutely fascinating. And I know that whenever we talk about mining or battery raw materials, it always generates so much discussion and debate. So we really, really do welcome that. Please do make sure to join in that discussion and debate in the comments below. But that is all that we have time for. Just a couple of things before you do go. Check out the description box below for how to come to one of our live shows. I personally can really, really recommend them. Next up, we're going to be in Sydney. So do come and join us. Thank you to Katie, who will be editing this episode. Thank you to you for listening. If you could do us a favor by commenting or subscribing, it really, really does help us out. It really ensures that we can carry on sharing the cool and interesting stuff in this clean energy transition. But that's it. If you have been, thank you for listening and watching.